Hello guys, welcome to a new video, and in this video we are going to talk about cryptographic concepts. And it was kind of a challenge for me to know all these cryptographic concepts. So it took me a little bit. I did a bunch of videos for IT Pro TV, CBT Nuggets, and also some Udemy videos. I read a lot of articles online just to get these different concepts, and also asked a lot of questions on Twitter, and a lot of people were able to answer me. And therefore, I think I'm ready to present you guys to these concepts. So let's go ahead and start with this PowerPoint that I put together. Took me a couple of days to put together since I was watching different videos and reading a lot of articles online. So let's go ahead and get started with this and see how I do. So the first one is that we are going to describe a key exchange. And a key exchange um, is also called key establishment. And it is a method in cryptography by which cryptographic keys are exchanged between two parties, allowing use of cryptographic algorithm. Okay, and some of them that are used are symmetric and asymmetric. And we are going to discuss that on another slide that I have coming on. Um, And then we hit this, we are going to now describe what a hash algorithm is. And well, hashing is a method used to verify data integrity. And the way it works is that a hash function is a process that takes a block of data and creates a small fixed sized hash value, right? So let's say you take a Word document and you hash it with either MD5 um, or SHA-1 or SHA-2. It gives you a fixed value, right? Um, and if anybody um, make a change to that file, um, what you could do is you can create another fixed value by running any of these three type of hashes. And if somebody changed that data, it will give you a whole different hash. It will give you a whole different fixed size hash. So that way, whenever you hash something and then you get that value, then you send it over to somebody, and then you send that person the fixed size hash value to that person, and that person runs the same algorithm that you use. And if he has a different hash value, a different fixed size hash value, then that person is going to know that somebody was messing with that data, and data integrity is no longer available. So that's how you can provide data integrity by hashing all your documents that you want to send over the public network, okay? And it is a one-way function, meaning that if two different computers take the same data and run the same hash function, they should get the same fixed size hash value, okay? And the three most popular types of hashes are as follows. So message digest 5, which creates a 128-bit digest. This one, not a lot of people use MD5 anymore because I believe it is now cracked. People are able to crack this. Um, what people use now is secure hash algorithm, so SHA-1, or secure hash algorithm 2, which is SHA-2, which can go from 224 bits and 512 bits. Okay, so this is how the hash function works. So over here you have your data, which is 400 um, kilobytes, and then you have right here 4,000 kilobytes. What you're going to do is you're going to run a hash algorithm, either RC4, SHA-256, or MD5, and it's going to give you this um, fixed length hash right here. And as you can see, it is completely different than the one that has 4,000 kilobytes on it. It gives you a whole different fixed value. And even if you change this to 401, it will give you a completely different fixed length than this one. It won't be anything near this value right here. And this process is not reversible at all. Just remember that for the exam. And let's move on, and we are going now to compare and contrast symmetric and asymmetric encryption, right? So an encryption algorithm that uses the same key or keys for encryption and the exact same key or keys for decryption is an example of symmetrical encryption algorithm. So whenever you use the key to locked data and then the same key to decrypt that data, it is a symmetrical encryption algorithm. Okay. So why is symmetrical encryption algorithm used? So they're used for VPNs today. The reason we use symmetrical is to encrypt the bulk of our data, and that is because it is a lot faster and it takes a lot less on the CPU usage. So it's a lot faster. For the same symmetrical encryption algorithm, that then it will be for a asymmetrical algorithm. So it is a lot faster than asymmetrical algorithm, which we're going to discuss on another slide. And a longer key means better security. A typical key length is 112 bits to 256 bits. The minimum key length is 128 for symmetrical encryption algorithms to be considered fairly safe. Again, the bigger the bits is the better the security. And here are some of the symmetric algorithm that you can use. As you can see right here, we have the DES and 3DES, which this does is run this one 3 times. Then we have the AES, which is the one used by the government. Then we have IDEA, then we have RC2, RC4, RC5, and RC6. And we also have Blowfish. And this is um, how it works, right? So we have a plain text data over here. What we do is we run that encryption algorithm. Let's say that we're going to use AES, which is approved by the government. And then what that's going to do is it's going to cipher the text data. And the data then is going to be the ciphertext data, right? The encrypted data is going to be sent to the receiver, which has that symmetrical key, the same key that I used to encrypt it. And then what it's going to use is it's going to run the same algorithm that I use, and I use AES, and it's going to use that key to decrypt that data that I sent, and then it's going to give me this plain text data, and then I will be able to read it. So now let's move on to asymmetrical encryption. So an example of an asymmetric algorithm is a public key algorithms. So instead of using the same key for encrypting and decrypting, we use two different keys that mathematically work together as a pair. So let's call these keys the public key encrypts, which is the public key, which is the one that encrypts, and the private key, which is the one that decrypts. And together they make a key pair. Okay, so for this asymmetrical, it takes longer, uses a lot more CPU, but it is safer. Um, and this is why it is not used to send a lot of data um, for VPN because it takes a lot longer. And for that reason, we use asymmetrical algorithms sparingly. Instead of using them to encrypt bulk data, we use asymmetric algorithms for things such as authenticating a VPN peer, right? So, and some of the algorithms that are used are RSA, DH, Elgamal, DSA, and also the ECC, the elliptic curve cryptography. And here's a picture of how this asymmetric um, encryption works. So we have Elise right here. Elise uses Bob's public key to encrypt the data, and whenever you use somebody's public key to encrypt the data, the only way to decrypt it is with that person's private key. So Elise knows Bob's public key um, because of the CA, which is the one that sends over the public key for Bob. Um, and once we know Bob's public key, we're able to encrypt it, and then we send it over to Bob, and Bob is the only one that has its private key. So he's going to be able to decrypt it with his private key. So let's say that somebody's doing like a man in the middle attack, which we talk in another video. If somebody hacks or gets in the middle and gets Bob's public key, he still won't be able to decrypt the data because Bob private key is kept in his computer. The private key is not sent over the network. The only thing that's going to be sent over the network is going to be a public key. Okay, and here's how this works. So the CA, the Certificate Authority, issues a digit a digital certification to the sender, and the sender gets a private and a public key from the CA. And what he's going to do now, he's going to share his digital signed public key to the receiver. So the receiver, let's see right here, private key. Yeah, so the um, the sender is going to send over his public key to the receiver, and the receiver over here is going to send over his public key, or is going to, okay, I'm sorry for that, guys. So whenever he gets that digital certificate, it's going to have his private key and his public key. Then he's going to share his public key, his signed public key, with the receiver over here. And the receiver, what he's going to do is he's going to encrypt the data with the sender public key, right? So he's going to encrypt the data and then send it over with this guy over here. And he's going to be able to decrypt it with his private key. And then he's going to be able to see his data. So now we are going to describe digital signatures, certificates, and PKI. So whenever you sign something, it often represents a commitment to follow through, or at least proof that you are who you say you are. In the world of cryptography, a digital signature provides three core benefits: authentication, data integrity, because you know that it came from that person when you sign it, and also provides non-repudiation. And now, not to be confused with a digital certificate, right? A digital certificate is something else, and it's not the same as uh, as a digital signature. So a digital certificate is an electronic document that identifies a device or a person, and this includes information such as the name of the person or organization, their address, and the public key of that person or device. Okay, so the digital certificate is the one that has the public key for that person or organization or device. And there are different types of certificates, including root certificates, identity certificates, which identify devices such as servers and other devices that want to participate in the PKI. And digital certificates aren't just for breakfast anymore. They can be used for clients who want to authenticate a web server to verify they are connected to the correct server using HTTPS. We use the TLS or transport security or transport layer security or secure socket layer. The SSL is not in use anymore. Um, what they use now is the TLS. Okay, and if you go to a website, um, let's go ahead to where you want to go. Let's go ahead to Amazon.com, and you're going to see right here that it has a key, and this key means that we have that Amazon certificate, and that certificate contains Amazon public key. And whenever I send data to Amazon, I'm going to use the public key to encrypt it, and then Amazon is going to be able to decrypt it with its private key, which is kept privately and it's not um, something that anybody knows about it. As you can see right here, my connection is secure and it is verified by Digit Cert Inc. And Digit Cert Inc. is a CA or a certificate authority. Okay, so let's go ahead and go back, keep presenting. Let's move on. And here's a picture of how a public key is sent. As you can see right here, it is hashed, and then we have the hash value, and then we encrypt it with the private key, and then we get a digital signature. This is how you get a digital signature, right? And this process is not reversible because if it was reversible, we were able to get that private key. Okay, so that's how a digital signature is created. So now let's move on to the PKI and what a PKI is. Well, the purpose of the public key infrastructure is to manage keys and certificates. By managing keys and certificates through a PKI, an organization establishes and maintains a trustworthy networking environment. A PKI enables the use of encryption and digital signature services across a wide variety of applications. Okay, so sorry for that. I want to go back to a symmetric algorithm. Okay, as you can see, you were probably wondering how is a symmetrical encryption or how is the public key sent over to somebody. So let's say that I'm going to need, let's go ahead. I have a chart actually. Um, so the key exchange. So I'm going to show you guys how it works. Let's say that for Amazon that uses TLS or the transport layer, so TLS and TLS, right, which is the transport layer security, and the transport layer security uses a symmetric encryption, and for that we need a shared public key. So how do I receive a shared public key? Well, the way it works is that the shared public key, um, the first thing that we do is we actually use a asymmetric encryption, and when we establish a asymmetric encryption, um, which works by me sending my public key over here and the other server sending me its public key over here. So now I have its public key so I can encrypt the data. So when I encrypt the data with the public key, with this server's public key, what's going to happen is I'm going to send it over, the data being encrypted over here, and then it's going to be able to decrypt it with its private key. And then he can just also, if he's going to send me something, he can use my public key that I have shared, and then I'm going to decrypt it with my private key. And after we establish that, uh, we are going to send our public share key, which is the symmetric encryption. So now, since we have a secure process or secure and encrypted, um, or we are able to send it via a secure protocol, what we're going to use is we are going to send our um, symmetric key, which is right here. So now I'm going to share my symmetric key with this server over here, and he's going to send his um, also his symmetric public key. And now after I have that, the hacker won't be able to get that public share key because we're actually sending it um, via asymmetric encryption, right? And since we have established that asymmetric encryption, what we do is we encrypt our data, right? So we encrypt that with this network public key or with this server public key right here, and we send our shared public key or symmetric public key to this server, and then the server is going to encrypt it with our public key, and it's going to send it over to us, and then we're going to be able to decrypt it with our asymmetric public key. So what I'm trying to say is, if you did not understand that, is that for symmetric to work, we need to use asymmetric key exchange first. Okay, so that's what I mean. Um, we need, let's see if I can write it right here. We need asymmetric encryption to send to send over our shared symmetric public key. That's what I meant. So for us to send our symmetric or share symmetric public key, because we want to send a lot of data, we first need to send it via asymmetric encryption, which is more secure than just sending our public key by itself without first establishing a asymmetric encryption. So we first establish an asymmetric encryption, and then with that asymmetric encryption, right, we encrypt the shared symmetric public key with the asymmetric public key of this server, and then we send it over, and then he's going to be able to see it. Okay, and that's what I meant by that. So we need a symmetric encryption to send over our shared symmetric public key. So that's how TLS works for a website, because TLS works with symmetric encryption. Okay. Okay. So this is all for this, not for this video, but for this slideshow. And let's just go ahead to the summary and hash algorithm. What is it? It is a fixed value used for data integrity. Symmetric use the same key to encrypt and decrypt. Okay. And it is a lot faster. Uses a lot less CPU, and it is used to encrypt VPN traffic and also to encrypt HTTPS. And an asymmetric private key and an asymmetric uses a private and a public key used to encrypt and decrypt. It is slower, uses a lot more CPUs, and it is used to encrypt the VPN authentication. And it is it is used to send over the symmetric public key or symmetric shared public key. And digital signatures is a signature used to sign data, and it provides integrity and non-repudiation. Certificates are issued by the CA, and it contains our public, our asymmetric, public, and private key. And a PKI is the infrastructure that manages keys and certificates. Okay. So now what we're going to do is we're going to go ahead and take a quiz that I created on Quizlet.com, and we are going to go over the cryptographic concepts. So let's go ahead and do that. Let's go ahead and take a test. The last one was 89%. And I'm going to go the option written. Okay, that's good. Create the test. So a asymmetric encryption tech. What is that? What are those? The asymmetric encryption technologies are, um, let's see, are TLS, IKE, and SSH. So let's go ahead and do this one B. Um, Symmetric. Actually, this is a C. Mm, okay, the same key is used to encrypt and decrypt, and it is fast and used for bulk data. So this one is A. And let's see, this one is actually B. This one is C. I think so, yeah, if I remember. So provides three core concepts: authentication, data integrity, and non-repudiation. This is a digital signature. Prefix length used for data integrity. This is a hash, SHA-1, MD5, and SHA-2. This is our hash algorithms. Now, true or false questions. A public key is used to encrypt and a private key to decrypt. It is low and it is used for authentication. This is true. An electronic document that identifies a device or person. It includes information such as the same name of the person or organization, their address, and public key of that person device. Is a digital signature. This is false because this is a digital certificate. Enables the use of encryption and digital signature services across a wide variety of applications. Use the encryption. So this is false because this is, I believe this is the PKI. So let's see how we did. And we got 100%. Here we go. So we are good to go. And I'm also going to add a link to the PowerPoint, to this drawing right here, and also to the quiz. And so thank you guys for watching. And if you guys enjoyed this video, go ahead and subscribe to my channel. And also, if you have a Twitter account, go ahead and follow me on Twitter at CCNA Daily Tips. Thank you guys for watching, and I'll see you on the next one. Bye bye.